Good morning and good evening, everyone. Welcome to one another Saturday live session. And today's session is to launch and demo a new open source AutoML framework, Auto Tensorflow. Thank you for taking time out and being here today. I would like to introduce today's presenter, Hasan Rafiq. Hasan is the creator of Auto Tensorflow and is going to deep dive on the package and show us how this framework can simplify model creation, model analysis, and in also building end-to-end
on the
model
package
pipelines.
and show us how this framework can.
Hasan is a cloud and ML architect, bringing rich experience with Google Cloud Platform, as well as wealth of knowledge on machine learning and TensorFlow. There is also Hasan's fourth session that he'll be talking on the AI Engineering channel. So welcome back, Hasan, to AI Engineering channel. Please join me in welcoming our speaker, and over to you, Hasan.
Thanks, Shri. And good morning, good evening, everyone, respectively where you are joining from. So let me share my screen and we'll talk about the library. And before that, what is the intuition of me building with this library? So let me share. All right. Okay, I guess my screen is visible. Okay.
Yes.
So let's start with something around machine learning, what machine learning is, and what is deep learning. Why did I come up with this library? What is the intuition behind? So and I'll also talk about what is the future roadmap, what are the current limitations on the library. So first of all, let me tell you that machine learning is like, I think we all know that what machine learning is, but if anyone is new here, machine learning is the field of computer science where we teach a machine or a computer to infer patterns from data. So a machine learns to create or inference patterns from data, and we don't have to build explicitly any computer logic for computation. Now, there's a lot of background required in terms of computer engineering. So you should know a programming language if you want to go into machine learning. And if you want to be a good machine learning engineer or a good data scientist, then you also need to know the math behind the algorithms, the math behind the problem statements. And you should also be able to debug well in terms of what is happening inside a machine learning model. And so that you so for that you also need to be a good data engineer, because in machine learning we talk only about data, and there's no volume of data. There's no limit to the volume of data when you talk about machine learning or deep learning or any sort of data science or artificial intelligence topic. Okay, so when I've started this session, I've touched upon some words like data science, data exploration, data volume, programming language, machine learning framework, and these all things, they combine together to create a complete ecosystem for building a machine learning application. Okay, and once you build a machine learning model or machine learning application, you also have to work to sustain your application, to sustain your model, to make sure that your model is up to date with the business data that is changing. So let's say if I have a model which predicts clothing for me, that what's the best clothing that I should wear, or let's say it predicts or it suggests me a movie, or it suggests me a song, then that model has to be it has to be live, it has to be well updated, it has to know what's the latest going in the trend. So when we sum up all these terminologies together, it kind of seems really complicated to understand that how can a machine learning operation or a ML ops cycle or a full pipeline or a full ecosystem of machine learning model be maintained. It could be really difficult to maintain, and in reality it is actually difficult to maintain. For example, I and Shri, we belong to, so we on in our enterprise we work on really complicated machine learning systems where we not only train a machine learning model for once, but we maintain sustainable and regularly growing systems which are built to provide artificial intelligence or machine learning as a service. Okay, so there are a lot of frameworks. There are a lot of frameworks like Pandas, sklearn, scikit-learn, NumPy. These are like a lot of libraries in Python. You also have similar libraries like Spark, which is for big data. You have data ingestion libraries like Apache Beam. which all combine together to help you ingest the data, to help you understand the data, you explore the data, visualize the data. And then you have machine learning building frameworks like sklearn, TensorFlow, Keras, PyTorch, Cafe, Theanos. So you have all these frameworks which help you build machine learning models at scale and then deploy them on a cloud or on an on-premise or let's say mobile device. Okay, and so that means since it is so complicated, since it is so complicated, it may be required that we have to not know everything, but have to know almost like 70-80% of the things to be a good data scientist or a machine learning engineer. Okay, now I'm coming very close to why I built this library. So you would know that machine learning has been in trend for like 5-6 years now. And there are a lot of frameworks which have actually a huge market share. For example, TensorFlow is one of them. Keras, PyTorch is one of them. And they have a very huge share. So people who are like good in machine learning, people or let's say college students when they start with tutorials or a Python programmer or a normal software engineer, he can reach out and look at a lot of tutorials to build any machine learning model or a deep learning model. But the story does not end there. It starts from there. For any toy data set, building a machine learning model is easy. Okay, you have a tutorial, you pick up that tutorial. Let's say, for example, it's a Collab notebook. You pick up that notebook, run it, you get the results, and voila, it looks good. It looks easy. But the real problem starts when you get in your own customer data set or your own business problem data set. Or let's say you don't even have a data set. The problem starts at that point of the time. Okay, because you may not know how do you want to analyze your data, what should which pieces of the data set should you analyze. You need to know the background of the problem statement. You need to know data engineering fundamentals very well so that you can extract the data from all the sources, you can clean the data, you can pre-process it, you can do some feature engineering, a lot of these things. And you should also be really good in frameworks like TensorFlow, scikit-learn, Keras, PyTorch to build good models which can actually handle the latency and scale on requirements. Okay, so there are a lot of frameworks these days which are on the name of or on which are like automated and they have names like AutoML, for example. Or there is a very famous library called as PyCaret by Moez Ali, which is a complete machine learning automated machine learning framework built by Moez, and he also presented on this channel where he showed the automated machine learning capabilities. And there are a lot of other packages like Teapot, for example. There is also AutoKeras, which has been launched. Google has its own AutoML library. Amazon has its own AutoML library. And the basic fund of AutoML is also called as the low code or no code framework, wherein you don't have to do any sort of coding or you have to do minimal coding, and you just only have to focus on giving the data to the library, understanding what's happening, and not even understanding but calling the right methods so that each step gets called, and then the machine learning model is built. You can look at the model and then deploy it once it is ready. Okay, so this is called as automated ML. Here you don't need the knowledge of machine learning in depth, but you need to know the programming language, and you should be able to like build a very simple and a good model. Okay, now what I know is that you guys, a lot of you would be like repeat on this channel who may be knowing that TensorFlow is a enterprise renowned library. It is built by Google, but we all know that TensorFlow is actually difficult. It's not very easy. It's slightly difficult for people to take up for the first time. I have been working on TensorFlow for around 3-4 years now. And PyTorch, on the other hand, for example, is an easy library. Okay, people are really easily able to scale up or learn. The learning curve is not that steep. But the good part with TensorFlow is its ecosystem is really vast. Okay, a model that you build on TensorFlow can also be deployed on devices, can be deployed on edge devices, can be deployed on any operating system. You can reduce the model, you can shrink the model, expand the model, and then it is supported by most of the operating systems in the cloud. Whereas it's not always the case for different libraries. It also supports different devices like TPUs, GPUs, plus it has an easy integration with other frameworks. But on the other hand, coding in TensorFlow can be a nightmare. Okay, if you would have seen my previous sessions on AI engineering, you would have seen my first session was on TF dataset API, which was around how you can build scalable models using TensorFlow. And there were a lot of people who followed us, who responded us on the channel saying that there are still some errors that they were facing. People reached out to me and Shri separately after the session, that they would need help to understand certain concepts. And it explains well. You can go ahead and check on Stack Overflow. There are so many questions that are open. Plus, the documentation can get confusing sometimes. Okay, now I'm at the doorstep of why I created the library. Okay, so my library is Auto Tensorflow. You can go ahead and open it on GitHub using this address, github.com/Rafiq and Auto Tensorflow. Okay, and the main mission for my library is I wanted to make TensorFlow absolutely easy for all the people. Okay, which means I want to make it easy for not only data scientists. I want to make it easy for a fresher who is in, let's say, first year of the college or even at school. Okay, so I want it easy for anyone to be able to make models on TensorFlow, and this is my end mission for the library. Hence, that's the mission of the library. You can see it says build low-code automated TensorFlow what if explainable models in just 3 lines of code. Okay, so the first part says automated TensorFlow, which means, so in fact, let me start it this way, low code, which says that you don't have to write tons of lines. You just only have to write like 5 lines max. And 3 lines of code is, I'll tell you why do I say 3 lines of code. So with just 5 lines of code, automated TensorFlow means that you don't have to do anything else. You just have to call the methods. You don't need to know machine learning. You need not know what is TensorFlow. You need not know what is happening inside TensorFlow. How do I do this? How do I do that? How do I handle this error, that error? You don't have to do anything. It will automatically create the best model for you. And here you also need not know anything about hyperparameter tuning. Okay, so the framework itself can build the best model for you, tune its parameters, retrain it multiple number of times, get the best model for you. And also the part which I'm focusing on, because model reliability is not just by building a model. We should be able to explain a model, and this is the best punch of this library. It's like whatever model is being built by Auto TensorFlow, you can explain it. Even you don't have to explain it, the library itself will explain you the model through a UI. It will draw you a UI wherein you can actually play with the parameters of the data set, and you can check what is happening in the model. You can actually see things. I'll show you in the demo. Okay, and that's the main goal of the library. So just in 3 lines of code, you just have to start by importing the library, passing in your data set, calling the EDA method, then calling the modeling method, and then calling the final explanation method. I'll just quickly also talk what is happening inside the library, and I'll show you as well what's happening there. So Auto TensorFlow has been built on 3 TensorFlow ecosystem tools. This is TFX, which is also called as TensorFlow Extended. So I and Shri, we gave one session around like 5-6 months back on TFX. TensorFlow Extended is like an extension of TensorFlow, which provides you on scale pipelining or ML ops for TensorFlow models. It's actually really complex, but models built on TFX can either run on Apache Airflow, which is also called as Apache Beam, Apache Airflow pipelines, and it can also run on Kubeflow. Kubeflow is again built by Google specifically for ML ops. Then TF APIs. So TF APIs is like I have involved a lot of low-level APIs in the library under the hood. So there's a lot of things like protobuf, TF dataset APIs, TF low-level ops to make this library work. And what if tool. What if tool is another tool or another extension by Google built for TensorFlow. So this screenshot that you see over here is a screenshot or a snip of the what if tool. I'll be showing you in live what the what if tool looks like. So these things, they combine together to create the output of the TensorFlow Auto TensorFlow what if tool. And then the same things which I told you, heavy lifting like EDA, schema discovery, and all. And the best part is, once you have this model, we also give you the code for inferencing on the model. So there are a lot of tutorials which are already put in the section over here, so you can go ahead and check the tutorials, and I'll actually be showing you 2 tutorials that I have in this library. So without any further ado, I'll just quickly jump on one of the problem statements for this thing. So here is my model. Here is my model built for a classification scenario. Okay, so what I'm going to do is, and this tutorial you can very well run on. You can just download it from my GitHub, or you can directly open that, and when you open it, you'll get an option saying open in collab. Okay, so let the library connect, and what we'll do is we'll run this piece of code here. Okay, so right now the library is getting installed. So while this gets installed, so for example, so I have released this library version called as 1.0.1 because 1.0.0 was my test version. Um, I still have a lot of future plans for this, but I'll explain my future plans for the library at the end of this whole session. And there are also some known limitations. So I'll show you how you can, if you want to contribute, you can also go ahead and do it. I'll be talking about all these things. So right now, quickly, what the library is doing is it is installing all the dependencies like TFX. It is installing Apache Beam. It is installing Keras Tuner with widget and all the other required libraries. It takes like 30 seconds, let it install, and then we'll restart the runtime. Okay, I think it installed, so I'll click on restart runtime. Restarting is required so that all the libraries which have been installed, they get affected, they can come into effect. It says initializing. All right, it initialized. Now just one line of import, so you have to say from auto underscore tensorflow.tfa import tf auto. Okay, that went well. Now what I'm doing is, so right now if I show you, I'll open this section as well. So right now I don't have anything. This is by default the factory image of Google Colab. What I'm going to do next is I'm going to create 2 empty directories, train data and test data. So let me run it. Okay, and I'll keep on refreshing what is happening in the directory structure. So right now these directories are both empty. And what I'm going to do is I'm going to pull my data set. So this is a custom data set that I built for this model. This is like a data set which tells me whether an invoice entry from ERP is old or not. So we pulled it for one of our toy. So this is one of our toy data set which has close to 8,000 records, and 8,000 split into 2 part 80/20, 6,600 in like train data set and 1,600, close to 1,600 in test. So what I'm going to do is I'm going to pull this from my GitHub. So very easy, I pulled it. I'll refresh the folders so I can see train and eval. Now what I'm going to do is I'm going to close this for time being. So when you have to start the TensorFlow auto engine, what you do is you say TFA or any variable is equal to TF auto. You pass the paths of the train data. So wherever your train data CSV files are present, they can be multiple. You can have sharded files, you can have tons of files. And the good part about this library is you can have big data. You can have big data capabilities. So even if you have data size which is more than your RAM, let's say 10 GB, 50 GB, 100 GB, you just put it in this folder. It will still manage to run it. Okay, you don't have to worry about that. Second thing is you pass the path for the test data as well, and then you pass a path route. Okay, so the essential intuition is the requirement is train data path, test data path, and a directory which TF auto will use to create its intermediate files. So this directory path route should not actually be existing. So if I open this again, TF auto is all actually not existing. Now what I'll do is I'll quickly run this step, TF auto. Okay, and if I refresh, it has created a section, a folder called as TF auto with some required folders over here, required directory. Okay, nothing else has happened. Now the first step is where the magic starts, and so the step 1 is I call TFA dot step data explore, and visualization is equal to true. That's it. I don't have to do. And what the step internally will do is it will pick up all the files that are there in both your test schema and training schema, and then it will start analyzing the schema of your files. It will analyze the distributions of your data set. It will analyze what are the anomalies in your data set, and it will show you the visualizations of the data. Let me go full screen here. Okay. So internally, what it does is internally it calls TFX's pipelines. So I've worked hard on this thing. I mean, it was really difficult to make it work here, but internally it calls all methods from TFX and shows the visualization. So I hope it's quite clear for all. So what it does is, after running the patterns over here, it shows that these are the columns that are there in my data set. So it says these are some internal names like difference in the goods received and invoice received, purchase organization, number of days, and all. And it says that the type the type that has been inferenced is this is a string column. Everything else is integer. This is string column. Plus domain means that if it is a string, then what are the possible values which are there? So I'll show you everything which happens over here. Okay. And the powerful part of this library is, again, so whatever it has inferred from the data set, whatever it has happened over there, it is showing everything, all the inferences, all the statistics, all the descriptive statistics of numerical features as well as categorical features from both my training set as well as the test set. So you can see that for numerical features in my training set, so this is training data statistics. For this column EK.org, for example, it says minimum value is 1, maximum value is 2. There are no zeros. But for these columns, for example, there are some zeros, there are some nulls, for example, over here. Okay, and these are the mean, and everything. Now, similar thing for categorical variables. It shows me that there are 3 unique values. What are their top frequency? What is the top occurring value? And I can use this information to further understand my data set. Now, a typical data scientist, for example, he may think that they may want to think that this information may not be enough. But let me tell you, when you build an automated machine learning model, you want to build a model as quickly as possible, be able to explain it, and it should be acceptable in its run one. And that is exactly what AutoML does. Okay, so it understands your data as it is available. It has not done any feature engineering or any special thing over here. It has just understood what's there in your raw data set. Okay, and you can understand and go ahead and build the model on top of it. Same thing that has done. So these are the statistics for the test data or the eval file which was there. Same things all available. You can see, you can try to understand if the distributions, for example, of every variable in the test set looks similar to the distributions of the training sets. For example, if I pick up this variable nodlgr, this is the distribution from my training set. So I can see that 0 to 20 has a high frequency, but others I have a mean somewhere around 150. Okay, and if I go back to the the test set, I can look that this is a similar distribution. Okay, so I can say that the split that I have actually done before sending it to the library, it's well done. But even if you don't do it, you don't have to worry about it. This is just something for people who already have like advanced knowledge in machine learning and all available. Now I'll show you the folder structure. I'll refresh it. Okay, now internally what has happened is, let me minimize these other things. Internally, you can see earlier there was just few files, but internally, after running the whole TFX ecosystem for exploratory data analysis, the library has generated a lot of files. Okay, so one file that I would like to show you is config.json. This is explicitly built by me in this framework. What I do is, after inferencing everything about the data, I push everything in a config file. Now you need not know. This is just something which I'm sharing you in the internals of what is happening in the library. So what I do is I store all the schema statistics, all the information earned and learned about my schema in this file. So for example, what is the root path? What is the data schema? So every column that is there, what was its type, whether it is a required or not, domain, feature, min, max, and if it is categorical, then what were the possible categorical values? And there's also other parts. So let's say so this library has automated feature that, let's say if there is a column or if there is a feature which has number of unique values more than 20% of the number of rows of the complete data, then it automatically takes that as a free text column. So for example, if I'm pulling the live streaming data from Twitter, then there could be a column which says tweet. Now the number of unique tweets will be different, okay, and it may be the same number. It may be equal to the number of rows. So in that case, it will automatically understand that it is a textual column. The model cannot take it as a categorical column and has to handle it differently. Okay, so this library is also capable of handling a free text column. So internally, it uses a TF model. I'll explain you how it handles text features, but internally, it uses a TF model to uh, to create models on top of the feature text column. Okay. Now, step one is done. Step two is I have already done the EDA. Okay, so I said 3 steps. Step one is done. Step two is I want the model to be built out. Now, for the model to be built, there are 2 things that I have to pass, which is well obvious. What is the label column? The label column, for example, in this is status, and I can see that status has only 2 values, 0 and 1 over here. Okay, and I'm saying that I want to build a classification type of model. Now, some libraries they don't allow you to pass the model type, but I've kept it open because I see it as a gap. I leave it on the user completely that if they want to change whether it is a regression model or a classification model, they should have complete control. Okay, then there is also a parameter called as model complexity, which I have not passed. What model complexity means is, so I told you that internally the library is capable of doing hyperparameter tuning. Okay, now let's say I don't, and hyperparameter tuning means the model has to search for different hyperparameters for the best working model. Okay, now some people may want to just check that, okay, no, I don't want to like build a very good model right now, but I want to build a deployable model right now. Okay, we want to do a quick POC and we want to show it to our client that, okay, this is a model which is well built, and we want to just put it in like some POC system for A/B testing of the whole pipeline. So for them, what they can do is they can set model complexity is equal to 0 and just run the model. It will simply create the model with default parameters without any hyperparameter tuning. If I don't pass this parameter, it will run hyperparameter tuning. And in the future releases, what I'm going to do is, right now there are only 2 possible values, 0 and 1, but there would be complexity levels, for example, 2, 3, 4, and 5, which will allow that as you increase the model complexity, your model will take more time to train. So there will be more searches, more horizontal and vertical searches for more number of feature engineerings that will happen inside automatically. Okay, and some people may be thinking that what is the capability of the library? What kind of models can it build right now? So for now, I've only focused on building classification and regression models on structured data. So let's say if you have a CSV file and you want to build only a classification or a regression model, that is only possible for now. But that does not mean I am not going to work on other things like audio or video or images or time series in the version 1.0.1 plus. So basically, it could either be 2 or 3. My target is to build to be able to like enable this library so that one can build an image classifier or an object detection model in similar 3 steps, and that would all be explainable. Okay, without any further steps, what I'll do is I am going to start an AutoML training for this thing, but I'll let it run in a full mode. Okay, so here it will take like 2 to 3 minutes, like 1 or 2 minutes for the model to get trained. Internally, what it is doing is it is building a wide and deep model with multiple layers in between, and it has started to tune the parameters. So there are different parameters like number of what is the learning rate, number of neurons in the first layer, second layer, number of what is the regularization parameter and all. So while it trains, I'll take a pause, and Shiri, we can take any questions in between if we have.
Yeah. So, Asan, more than a question, right? Like you said, it supports text data, right?
Right.
Currently. So, when you say text data, like, does it support a proper NLP pipeline, or with structured data, you have text attribute? How does it support that?
So for example, so here, Shri, what I've done is it does not do any pre-processing like cleaning on the text data, but internally I have pulled a TF hub model, which is the STS encoder for now, and it runs its own tokenization internally. So what it does is it takes the data, it gets the embeddings from the pre-trained model and uses the embedding directly in the input for training this model. So it's less just like that. I've not added any pre-processing here internally. The
Got it.
best part is TF hub models. The best part is TF hub text models. They have their own internal handling for tokenization, pre-processing, and everything. So we are like free from all that. So we are using the best of TF hub as well in this.
Got it. So basically, it's mostly a pre-trained encoder that you are using, and you're fitting a
Yes.
classification head to it.
Yes. And
Got
in
it.
upcoming future, what we'll allow is as we add the model complexity 3 or 4 level, I'll add it. I'll allow the text module as well to be retrainable.
Got it. Got it. So there's one question on anomaly detection, right? So you
Right.
have plans for that as well in your Auto TensorFlow package.
Correct. Right. Right. That has been handled. So TFX internally has capability for handling anomalies. What it does is it calculates descriptive statistics for both the distributions, and let's say it finds some anomaly. Let's say if there is some skewness kind of a thing, or if there is some if the number of counts for a categorical feature are not sitting in well together, then it automatically tells me that the my data is not having is my data is having anomaly. So I'll show you quickly. I think over here I missed this part. It says no anomalies found. This is by standard available in TFX.
Got it. But so once you say like there's an anomaly, right,
Right.
Hassan, how do you incorporate that in the model? Is that automatic, or we have to do some additional
So
processing and send it across?
what I've done is for now I've not specifically handled that. I let the model train, but in my coming problems in my coming releases, what I'm planning is so the config.json file gets created after the first step. So if there is any column which is, let's say, anomalous, we would be allowing the user to mark that column as skipped. Okay, I think I missed that part, but let me quickly show you. In the config.json file, and this is for advanced users, I have added this parameter or decorator called as ignore features. So let's say there is an advanced user, okay, and they say that no, I don't want to use this column in my model. I don't want my AutoML model to pick up this column at all. Then they can just add this column over here and run the further steps like model training and all. So the AutoML model will, in that case, will skip this feature and not use it. So the same funda can be used for anomaly as well in going forward.
Got it. Got it. So the next question is from Amit. Amit is asking like, how does the package handle hyperparameter optimization? Is it automatic? I will also add one more question to it. Like, can we fine tune the hyperparameter to say I just want to run for say like X number of hyperparameter range? Can I do
Yes,
that?
yes.
Hmm.
Yes, so internally, for now, what I've done is I have provided a range, an integer range for most of the parameters. For example, in the first layer, I'll just show you this one. For example, it is tuning the pre-final neuron number of neurons. And how it does this? I've set that pick up all the possibilities from 32 number of neurons to 512. The best part is there are a lot of tuning libraries like Keras Tuner, and I think Ram showed on his previous session there was one called a Storm Tuner, which was really awesome. But I went with this thing. So internally, I think we don't have to worry that it has to test all the features. I've given it a good space for checking all the possible hyperparameter options available.
So you're
So
using Keras tuner in the back end, right?
Keras Tuner in the background.
Okay.
Yeah, these are all the standard outputs from Keras Tuner over here.
Got it. Got it. That's what I thought. Seeing the output format.
Yeah.
Okay. Hmm. Okay. So the next question is from Strofa. I'm sorry if I not spelled the name correctly. Does it work only on English text or it can handle other languages? Um,
It can handle other languages as well. Yeah,
mm, so the
taken the
encoder that you are using that supports other languages, right?
yes, yeah, exactly.
Got it. So the next question is from Glad. Can we change the data schema?
Oh, that's a good question, and I this is close to my heart, Shri. So what I've done is it's possible to change the data schema. Okay, for example, let's say I have a column which is by chance. I mean, let's say I have this column as integer, and I want to make it as categorical. Okay, so what I can do is I can go ahead and go ahead in this file. I can make it as categorical and I can add the possible values. But right now, the feature is if I make it as categorical, then I'll also have to provide manually the possible categorical values. I've not handled that stuff yet. At how do I let the library infer the possible categorical values? But I'll add all these things in the future. So again, it is a plan in my future releases that if someone changes the schema for an integer column to string or categorical or free text, for example, then if there is something something else, then how do we handle it? So it's again there. You can change any integer column to string directly. That has no repercussions. That is no problem. But the only caveat here is if I change anything from integer to string, for example, then right now I will have to provide the possible
Got it.
categorical values as well.
Got it. Got it.
Yeah.
Got it. So that is a message from Mohammed, uh, quoting that it's your stellar, congratulations on your stellar work, very inspiring. Um, the one more question from Gulab. Gulab is basically asking about the main advantage of Auto TensorFlow over other AutoML. That is,
Right.
can it handle big data? So I'll just add on to that question. Can you talk about how you handle distribution strategy, TensorFlow distribution
Yeah.
strategy, if you're start and if you're already handling it?
Yeah. So TensorFlow over here, I'm the default training strategy is TF mirrored strategy. So if you have a GPU available in Colab or anywhere, then by default the library takes GPUs for training the model. The second part I would like to add, which I want to answer to Gulab, is yes, it can handle big data. And the third part, and the punch of this is something which I've not even showed yet. Okay, so that's the what if tool, which is not there in any of the AutoML libraries, not even any on any of the clouds, for example, AWS or GCP. But this is only the only library that provides you that visualization for that in single step. Okay, so the three parts is you can quickly train a model without what's happening inside the model. Second part is you can train it on big data, definitely. Third part is you can train it on GPUs and TPUs if those are available. And fourth part is you can explain what's happening inside the model. So these are like the four punches and a lot many to come in. I hope that answers the question.
Yeah, got it. So there are a few more questions coming in. What we can do, I think this completed. You continue with the session, and then we will take the questions.
Okay, sure, absolutely. All right. So the training has closed, and the sparse categorical accuracy for this model, I think, should be the best one over here, like 9613. And after the training has closed, you can see that the model would have been exported in the model directory over here. So one can directly pick it up. I'll show you how do you put inferencing on the model. But now, so most of the libraries and deep learning thing, it does not close over here. Okay, these days, and the trust, my second part of my third part of the mission for creating this library is how do I enable more trust on all these models. Okay, so for that, what I've done is I've added a what if simulation. Okay, what I'll do is I'll quickly run it. Now, what it does is it picks up data from my evaluation set. It picks up 100 records, top 100 records from my evaluation set, and it just gives you the complete what if analysis of the whole tool. Okay, let me see if I can bring this in another tab. Okay, all right. So I'm not sure how many of you are already aware about this thing. But let's say I have to explain the model. Okay, so machine learning is not only building a model. Machine learning is how do you handle things like biasness, which also means fairness indication. How do you explain a model, which means partial dependency plots, and how do you tune the model? Okay, which is again performance and fairness. Okay, so let's say I have this model trained, okay, and I want to dice it by seeing how did my model do well across let's say different categories. So for example, if you see my x-axis, my y-axis is the true label, okay, and my x-axis is the predicted label. So you can see over here very well, it's a visual inference. I can click on this data, I can see what was this data point which was actually predicted incorrectly by my model, and I can see what's happening over here. Okay, now let's say I want to further scatter and I want to like further drill it down as per let's say another feature called as this thing. Then I can also see that for features which are going wrong, the number of days this parameter has a high value. Okay, I can do any sort of that slicing and dicing for any two features, and I can let my model, I can understand what is happening inside my model. Okay, so this is a very good feature. It is used by data scientists, machine learning engineers a lot. Okay, and the second part is, let's say, what it is called as what if. So what I do is, let's say if I want to reduce this parameter, okay, and I want to rerun, then how will it react? Okay, so it shows me if I change this to 20, then my class 0 goes up by 0.03 and class 1 comes down by minus 0.03. Excellent feature. I can guarantee you this is not there in any other libraries right now which are running AutoML. Okay. The second part is partial dependence plots. Now, partial dependence plots is another feature which is used by lot of advanced data scientists. What they do is they tell you that for a parameter, for example, this is difference in goods received and invoice received number of days. How does my this parameter reacts? How does it like I would say correlate with my flag, with my final, or with my label? Okay, so it says that as the number of days increases, my this is how the inference score changes. Okay, so I can also see it for other parameters, and I'll also show you a regression problem where these are basically used. Okay, um, I'll show you something else over here. For example, scenario. So it shows me that my one flag has basically inference value as A. So this is also used. The other part that I would like to show you is performance and fairness, which is the most important thing to understand. Is my model biased? So for example, I provide the ground truth variable. It was status. Okay, and it shows you now if I want to slice it on, let's say, parameter bpatd. Okay, so for all the ranges, so there were two ranges that my model created. This is actually a numerical feature which has three possible values: 0 to 30, 30 to 60, and 60 to 90. It tells me that for the values which are there in range 60 to 90, my accuracy is pretty good. My F1 score is 0.98. But when I move down to 30 to 60, my accuracy is a little lesser. It's not that bad, but it's still good. Now let's pick up another slice. Another slice, like for example, NODL GR. So it says very well that my model has done excellent job on the feature value 0 to 127. But when it goes up, then my model is actually not performing that well. It's like 0.95. Okay, so I may want to check that what is happening there. Now I see that there are a lot of false positives, a lot of false negatives that are coming in this area. Okay, and I may want to reduce them. So basically the part here is you can understand the fairness of the model. You can play with different attributes. You can understand the fairness of the model. You can tune it. You can make it better. And how you can make it better? Let's say I understand that this parameter is, let's say, not doing very well. For example, then I can go ahead to the business. I can ask, I can do some advanced analysis outside this library. Now I can pick up this bunch of data in some analyzing tool, for example, pandas, or let's say in Tableau. I understand what is happening in for different features, and I can then further explore the data. But this library gives you an excellent explanation of the base model that has been built automatically by the model. And it's not just any base model, it is giving you a good accuracy. It's giving you like 0.95, 0.96 F1 score in the overall. Okay, so definitely it is giving you a very good accuracy, and you can use this model. But if you want to deep dive, it is also available in that option as well. Plus, finally, the same things that were available in my EDA chart by the model, they are also available for you to check over here. Okay, so you can see all sorts of distributions, even for the inference value and whether the inference were correct or not correct. So I would not be, so this is not a session for what if tool, but this feature, if you have been able to like relate to this tool, you would actually be able to understand that how powerful Auto Tensorflow is coming with this tool. It allows you to completely like debug what's happening inside your model and then gain trust. So if, for example, if a client comes back asking you that, hey, how have you built the model? Can you explain me that what is the relationship between this feature and the status that you're predicting? Then you can actually show them that, hey, this is the feature. Or let's say if they ask you, how is this feature reacting with the final variable? Then you can actually show that, okay, there's a lot less correlation, but and then you can explain the model. So this is how you explain locally the what ifs. I'll take a pause, like quick pause for like 2 minutes, in case if you want to take any special questions here, Shri.
Yeah. Why don't we do one thing? Like, why don't you finish the serving part as well, and
Okay.
then we can take the questions. So that way, like, we can park the questions for the end.
Sure. What I'll do is, while we'll take questions, I'll also have another model for regression, which is the housing price. So while we're taking the questions, we'll let that pipeline run, and we'll also show. I wanted to show the partial dependence plots features for a regression model as well. Okay.
Okay.
All right. So just ignore these errors over here. This is something like standard coming in from TensorFlow serving, but it's not a problem. So what we're doing now is we are actually running the model, and we are going to use it for inferencing. Okay. So this is now I'm setting up TMS. TMS is TensorFlow Model Server. I'm installing it on Colab. Let it install quickly. Okay. And then I'm going to run it. Okay. I think it has started a job on level on 8501. These are the logs. And what I'm going to do now is, so this is the standard way of calling TensorFlow model server model. So if you deploy this model on GCP, AWS, Azure, and you're using TMS as the service by default, which every cloud uses for TensorFlow models, this is the JSON request that you would be sending in. Okay. So for example, this is one JSON request with all the parameters. If I send it, I get back the probability for both the classes. Sorry for the this thing, because it's like text formatted, so the slash n has not been respected by Collab over here. But this is exactly what you're gonna do. And this is the end of the classification. So you can see it's absolutely easy. You did not have to do, and these are not any coding steps. Basically, TensorFlow model serving, you don't have to worry at all. You just have to pick up your file from here. You just have to extract it and upload it on GCP or AWS or Azure, and the model gets deployed. And how you can test the model is, you just simply have to pass this request or any request that you have to the model, and you can ping it and get the results. Okay, now I'll take a pause, and we can take questions, Shri, on
Yeah.
this one.
Yeah.
Meanwhile, I'll run the other model as well, which is the regression model. We'll show the results in the end.
Got it. Got it. So before going into the questions, Ram is also in the session, and he has said, Hasan,
Yeah,
it's a fantastic library. The addition of what if tool is a great differentiator on top of performant models. I would highly recommend to anyone. And if
thank
somebody
you,
is
Ram.
new to channel, most of you might know Ram. Ram also has an TensorFlow based AutoML library called Deep AutoML. He did a session a couple of weeks back. It's another amazing library that he has done. It supports image data, text data, and all. You should go and check it out. Thanks, Ram, for showing up your support here.
Thanks, Ram. Absolutely.
So the next question is, what is from Venkatesh? Have you also tested for various data sets the auto hyperparameter part, since the hyperparameter is not specific as of now, not user specific as of now?
Right. So yeah, definitely. This is coming from whom? See, this is coming from
Venkatesh.
Venkatesh. Venkatesh. Okay. So yeah, Venkat, this is a very good question actually, and let me be transparent here and true. So it's not easy. I would say it's not easy for any library to handle automatically these things, like what are the possible hyperparameters. But what so for any AutoML library, what we usually do is a simple funda. We try to put everything that's there, and we optimize it in such a way. So for example, I've given an option called as model complexity. So what I urge strongly is, when you use this library, don't start with level 1 as the model complexity. Start with model complexity 0. Check if the model is giving you acceptable accuracy. Let's say if it is not giving you acceptable accuracy, then you move to model complexity 1 or 2. And internally, what we're doing in this library is that at every level, we are increasing more capability in the model. For example, I'm adding feature cross, or I'm adding, let's say, binning, or I'm adding, let's say, categorization, or I'm adding more space for the model to search for hyperparameter tuning, or let's say adding more parameters in that space is what is happening inside. So we're trying to add as many parameters as possible, but definitely there's one thing which is always called and set for all AutoML library is, if possible, before using an AutoML library, if you want, you can definitely do some feature engineering before sending it to the AutoML model. So even for Google AutoML, if you see, Google is strongly urged that in case if you want to do some pre-processing before sending it to AutoML, you're very well advised to do that, because see what happens is the knowledge of the framework, the business knowledge, or let's say the domain knowledge, is something which the model will never be able to infer. Okay, that can only be provided by a human being when they're providing the data. So if you can do some pre-processing before sending it to the AutoML library, and not only Auto TensorFlow, to any library, that will definitely increase the accuracy. That's my long answer short over here. Yeah.
Got it. And I think that's a known fact, right? Like AutoML is not a replacement for a data scientist, rather assistant. So it's not that you feed the data and AutoML libraries are going to do wonders. So if you have any domain knowledge or application specific knowledge, try to incorporate that as features and then pass on to AutoML library. So that's where the real data scientist work comes into play.
Right.
So the next one is Mohammed Arsalan again. How does autopilot will affect this library? Maybe I did not get this question.
Hmm.
Yeah, is he talking about H2 autopilot or something like that?
Maybe. Yeah.
Mohammed, you
Not
want to
sure.
maybe rephrase the question and pass it across so that we can answer it? So the next question is from Gulab. Is there any library to explain the anomalous point? I think PyOD is there, Gulab. You can
Right.
check PyOD, and there's one I forgot the name of library. It came. It was very famous. It supports model comparison as well. I'll find that out and maybe I'll put it in the chat if I found it or find it out.
Okay. Okay.
So the next question is from Neil Hasan. So this is great, Hasan. Would you be adding support for fine-tuning NLP transform models for classification, NER, Q&A, summarization with the same three-step process?
Oh, thank you, Neil. By the
Hmm.
way, I think this is a big request. Probably Hugging Face is the intuition coming in here. Let's say if I can go ahead and try to add it, definitely I'll do it. I'll add it in my plan, but I've not thought over it yet, because it's a huge domain that can definitely be targeted. But yeah, it's a good idea. I'll put it in my roadmap.
Hmm, got it. So Ari is asking question, can we see explanation of, I think the explanation was presented. I think this question came
Right.
before the
Yeah.
explanation was there. So we will script that. There's a follow-up from question from Gulab. Can we also explain single or group collective anomalous point now or any such feature plan?
Yeah, yeah.
So,
It's available by default, Gulab. So you can go ahead and explain even a single point over here. So I think you probably missed that. So when you go to the library over here in data points, is okay. Oh, if you're telling the single explanation using libraries like Lime or Shap, then I have not added it yet, but definitely we
no,
can
no.
go
The
ahead and add
question
it.
is question from Gulab is I think like specific to the anomalous point.
Oh, okay,
Can we
sorry.
do single as well as group? So there will be a group of attributes that can combine and be anomaly, right?
Okay, sorry, I
Mm,
missed that. Yeah,
mm. So
yeah.
is that possible? That's the question.
For now, I have not added it, but I think like Shri, you were talking that there is a library which explains anomalous points.
Yeah. So one thing
Maybe we
is
can do that.
PyOD is there. I would say like see if you want to do a group or collective, then better to more like build your own model for that. I have a session on autoencoders which does that. Because like most of your data when it comes to group or collective may not be in a linear space, it will be a non-linear space, and that's where like autoencoder really shines. If it's in linear space, then you can run your own isolation forest or some other
Correct,
algorithms.
correct.
This is an interesting question from Pradeep. Pradeep is asking, can you talk at the end about the overall process you have to go through to create a library like this with multiple features, the high
Right,
level process? I know there's a lot of effort that has gone beyond this
right,
library, and creating
right,
libraries is
right,
not easy. So can you
right, right.
explain the journey?
Pradeep, you have asked the favorite question for me. I was thinking if someone would come to that question, because that explains how much of hard work has gone in. And I think there can be multiple answers. We also have Ram on the session. He's from Google, and he's been doing a fantastic work there. And Shri is involved. So the part is whenever you build a library. So my thought process was I'll follow the Pareto rule, which says 80-10-10, which is like 80% of the problems can be solved like you can solve like most of the problems with the 80% of the data. Okay, so I went ahead and checked that on the Kaggle, what are the most of the data sets usually about, and when on LinkedIn and all, what are the main problem statements that people usually cover. So I thought that right now let's not focus on everything. I'm focusing only on regression and classification for structured data. Okay, and time series, for example, is the next thing, which is the which is the big thing which is usually required by people. So I started building my library with that in mind, that I'll build something for regression and classification. And the second and third part, which are the main pain points, are the pain points which I've usually seen people asking on LinkedIn, and my own seniors at my firm, for example, they say that how do you explain a model? So when you have to build a model for a financial institution or for a banking firm, which I think she knows better than me, then those models, they have to be explainable. You cannot just go ahead and deploy a model for those such of industries. Okay, so in that case, I was very well having that mindset and having that plan in my mind, that this is the problem, this is the data domain that I have to cover, these are the features that have to be added. And there's also one more very important feature that I'm planning, which is probably an intuition from Depot, is that I would be giving a complete code of the library. So whatever pipeline code is being used inside, that would be deployed as, that would be available as a Python file, which you can pick up, you can tweak it going forward, and you can build that model. So for example, let's say you want to add another calculation internally, a feature engineering that you want to do as per your business requirement, and let's say it is complex and you want to add it, you will be able to do that directly inside the model going forward. So these are some of the pain points that I covered. And then building the library is day night of effort, talking with friends, checking on Google, reading through documentation, and then building the library. Yeah, that's it.
Got it. That will be nice, like if you have the TensorFlow code, because one of the biggest challenges with TensorFlow is the TF data API,
Correct.
TFX, and all the APIs. Building that code itself, if you give the code, it will be a skeleton code that anybody can take and tweak it across.
Okay. Yeah.
Hmm. So the next question is from Venkatesh again. Venkatesh is asking, is the handling null values taken care automatically? If so, are you using mean, median for continuous variable mode, and what are you using for categorical rather?
Right. So Venkatesh, what I've done over here is I have let the means be handled naturally. So what I've seen is we're not handling it through a null values through a natural way. So what we're doing is we're replacing it with a fixed value right now. Okay, and we're letting the model build it. But the actual plan that I'm going to do next is so let's say if there's a null attribute, then I am having this in my plan that I'll add more features internally. For example, there will be a feature which will be having null columns, null values, null rows replaced with mean. One feature will have null rows replaced with median, for example, and then build the complete model on top of it. But definitely, there are a lot of things which are coming up. I have a lot of things in my plan already. I could not cover everything because it's huge. It will still take me like 2 to 3 months to make this cover up almost everything. But yeah, that's the plan going forward.
Got it, got it. And there's again a message from Arun for you. I really like the what if tool. It sets this library apart from others.
Thank
Uh,
you, Arun.
Paramita, you're asking for feedback from this. In my live webinar, we don't do feedback form. If you want, you can scold us here. If you like, give us support on LinkedIn, share this video, or that's what it is. So there's no feedback form. So next question is from Ram. Ram is asking, can you explain the train validation split and what the performance of the model will be like on test data using a CSV file? Currently, it's only using JSON payloads.
Right, right. So Ram, over here, what I've done is in the logs, I've not specifically added any message in the end, but in the logs, we can see that this is the sparse categorical accuracy. But if you want to, let's say, pass another file completely, a new file in the model, I've not added that as a feature, but definitely I can see from your comment that it would be a good add-on. So I
Got
can
it.
go ahead and add it. Yeah,
Got it. Evaluate and predict on batch data will be good as well, a CSV file. Yeah.
correct, correct.
Mm. So next question is from Stoffa again. So you mentioned time series and image classification and object detection as feature additions to the library. How about audio classification? Would that be on the
Oh,
radar?
that's definitely a very good use case. I have built models for audio classification specifically earlier, and I think that can be a good case. We can definitely I can definitely put that. So what I'm going to do now is I'm going to take this whole chat sheet, and I'll put it as a PR in my
Yeah,
Kanban board.
got it, got it. And you already have an Kanban board, you said in
I
your
already have. I'll
introduction
show it
video.
to everyone. Yeah, I have a
Yeah,
Kanban board already
yeah.
that for that.
So,
Okay. Any so next question we can take.
yeah. So, Pradeep, thanks, Hasan, for responding to the life of and package developer in the backend. Great to get a peek inside the mind of a true builder. Maybe this is so. That's from Pradeep. Pradeep has asked one more question. Let me read it out. Maybe this is not the right event to address this, but I would like to see a session organized by you talking on builders like Asan Ram about how to go about building such utility. That's a nice suggestion, Pradeep. Maybe I'll try to see if I can get all three together and everybody can bombard questions to them. So let me try to do that.
Absolutely.
Yeah, I think that's the questions. Maybe you can go with the uh, with the one you ran it now, if it is
Yeah,
done.
yeah, yeah. It just ended. So okay, so this is the housing data set. I think most of you would be well aware about this data set. It's a very famous one, wherein we create a model to detect the prices of a house as per the number of rooms, bathrooms, square feet. Okay, so I was not able to show much on the partial dependence plots for my previous data set, but here you can actually see in the regression model. So let's say, yeah, looks good. So over here, for example, you can see that what happens as the number of rooms are increasing. How is it affecting my price? So you can see clearly the model that has been built automatically. So you can see that I did not touch anything. I just ran my code over there, and it built a fairly well model. So over here, if I increase the number of bathrooms, for example, then this is how my cost of the main of my home increases. If I and I'll show you something strange over here. So if you increase the number of bedrooms, okay, we think that the cost would actually go up, but if I tell you, the cost actually goes down. So this is one of a myth, for example, which has been very well clarified by the data set. So it shows you a negative correlation over here. Now, this is how you actually explain a model. So for example, if you build a model, if you already only just train a model, you won't be able to infer such statistics from just a model. Okay, you need to build any partial dependence plots, or you may need to build fairness indications and everything, so that you understand what is happening inside. Now let's say what happens when I increase the number of floors. So clearly it says that as the number of floors they increase, the prices of the house they increase. Okay. What if I have a basement? How does it affect my overall price? So you can see that it's a negative U curve. Okay, and so this is you can how you can play with the model, how you can check different things. And again, the next part over here is, let's say I want to check for a data point. This is, let's say, a data point, and what I want to do is I want to say that I increase the square feet. Okay, and right now the price is this. How will it affect my final thing? So if I increase the square feet by, let's say, I took it to this thing, it increased the price by 8676 units. So it's a lovely feature. I mean, I keep on playing with this feature throughout my model on what if tool, and it actually gains a lot of trust, helps me gain trust on the model that I've built. Next part is I can use this knowledge to add more features in, let's say, my dataset, and then I can rerun the changed or the pre-processed dataset again in my AutoML library. So that marks the end of the main demo. And what I wanted to show you is, so we also have a lot of future plans. There are some limitations. I'm sorry, there are some limitations on the library which I am still fixing, but I had to go through a lot of tough things on the TFX model, TFX framework, and I was not able to solve some things right now. But there are some limitations. So right now we're not supporting image or audio data, but definitely I think I'll be adding it. A quoted delimited CSVs is something which is missing on in the TFX library right now. So I've opened this with Google as a PR. It's open on GitHub already, and there is a bug that is also open. I'm in conversation with the TFX team as how we can add it. Second part is, right now classification only supports 0 to n variable. Basically, you need to have a numerical variable label. But I am adding this thing, and in my next release, which is 1.0.2, which should be available by next week, I will fix this part. you can have non-numerical labels as well. Okay, and future roadmap is definitely available. So all these things which are missing here are available. Plus a very powerful feature which I told you, I will be adding an option to download the full pipeline model code as a model as a Python code. So anyone who is like an expert in TensorFlow, or if not an expert, they would be able to play with the code just like I was playing with the what if tool, and build a model on like a advanced model on top of it. Okay, so go ahead and use the library. I would say pull the tutorials, run it in Colab, play with the things that are available, play with your dataset. If you have any issues, these are some of the issues which I've already opened. There is a Kanban board available. Please raise issues. If you want to support the project, please fork it. Ping me, message me. I'm available on LinkedIn. You can also reach out to Shri, and I can see how you can contribute to the library. Okay, that marks the end, Shri. So
Yeah.
I'll stop presenting if that's it.
Yeah, I think like Sarnath has said that this looks similar to the explainer dashboard what if tool. Yeah, so what if tool is an open source framework where a lot of packages have incorporated it. So you can see the UI is similar and the data is similar. The best thing about this is integrating with your end-to-end pipeline. You have one-stop place where you can basically check the EDA, build the model, and then using the model you can also do your what if analysis. That's what really stands out over here.
I was just reading through all the comments, and I think Gulab has given a really nice
Yeah,
comment in the end.
yeah, that's right. So it's just Jackass. He's telling like Anil Kapoor style.
Yeah.
Yeah. Again, like Rajan, amazing. Thanks a lot,
Thanks,
Hassan.
Rajan. Thank you so much.
Yeah. So I think like that's what we have questions. What you can do is if you have more questions, you can just put it in the comment of the video. The video will be live right after I end the podcast, and you can put it. And Hassan will try to answer that one. If Hassan is not seeing it, I'll make sure that I will even wake him up at uh, like late night and ask him, have him answer it. By the way, Asan, if you know him, he does not sleep. He does not like to sleep.
Oh
That's a
no.
different story. Hmm. Yeah, so that's about it. And thank you, Asan sir, for first of all for creating such a wonderful package. And second thing is like launching it in AI engineering channel. Thank you. You've always been very supportive. This is your fourth session. Thank you very
Thank you.
much for that. This package is amazing, and we will see a lot of new features that is getting added for other data set, which will increase the adoption. Thank you everyone for being here, watching this session. Just give it a try, and if you find any issues, let Asan know so that he can fix it. Basically, like we will, the more people try, the more wide ranges of data set we'll be dealing with, and we will get more feedback on the product. So just give your feedback to Asan so that Asan can fix it. So that's about it. Thank you.
Thank you all.